Banana cultivation is very important in Malaysia for both food security and supporting smallholder farmers. Traditionally, farmers propagate banana using suckers. However, this method can spread disease, lead to poor plant quality, and reduce overall productivity. To solve this, our project uses in vitro tissue cultures. This technique produces banana plantlets that are healthy, uniform, and disease-free, making them ideal for large-scale commercial production. Bananas are a major agricultural commodity in Malaysia, providing vital income for smallholder farmers. However, traditional propagation using suckers often spread disease, lead to uneven plant growth, and reduce overall yield, causing financial losses. Our project proposes in vitro tissue culture as a sustainable solution. This method allows mass production of banana plantlets that are healthy, uniform, and disease-free, ensuring consistent quality in faster growth. The production system is scientifically feasible, scalable, and designed to meet the needs of smallholder farmers. By using tissue culture plantlets, farmers can reduce losses from disease, improve yield, and lower long-term production costs. From a commercial perspective, these plantlets can be distributed to nurseries, agriculture cooperatives, and government programs at reasonable prices, promoting sustainable farming while supporting farmers' livelihood. Overall, this project combines biotechnology with practical agriculture solutions, offering significant economic, environmental, and social benefits.
I will present the project descriptions and the Gantt chart for our banana tissue culture project. Banana is an important crop in Malaysia, but traditional propagations using sucker is slow and can spread disease such as Panama disease. This disease causes serious losses to farmers. Therefore, tissue culture is used to produce disease-free and highly quality banana planted in large number. This project focuses on producing banana plantlet using tissue culture technique. Healthy mother plants are selected to ensure that good quality and uniform growth. The plantlet are grown in the laboratory and later transferred to the greenhouse condition before being planted in the field. The target beneficiaries and smallholder farmers who need reliable and healthy planting material. The scales of production is small to medium, which is suitable for local farming communities. Some challenges include contamination, high cost, and difficulty during assimilation when plantlet move from the lab to soil. To overcome this, we apply strict sterile technique, manage resource efficiently, and use a proper hardening process. According to the Gantt chart, the project starts in January with the selections of healthy plant, followed by the culture initiations and short multiplication, rooting acclimations and greenhouse growth, and finally field transfer to farmers and carry out until September. This timeline ensures that smooth and organized project implementations. Thank you.
Now we are going to look at the tissue culture techniques. Before going to that, I would like to explain briefly about the type of explant used. The shoot tip, which is apical meristem from healthy disease-free mother plant, is most commonly used because it contains actively dividing meristematic cell, which is high in regeneration potential and has low risk of viral and systemic pathogenic infection. That helps to maintain genetic fidelity, which is true to type, and also enables mass production of uniform plantlets. The first process is sterilization process. In the sterilization process, the first step is washing under running water, where it helps to remove soil and debris. Second thing is mild detergent treatment, which uses aseptic sterilization techniques such as ethanol and sodium hypochlorite usage. Multiple rinses with sterile distilled water is included to prevent bacterial and fungal contamination. These techniques and steps must be followed accordingly because it is essential for successful culture establishment. Talking about the in vitro culture stages, there are five in it. The first thing is culture initiation. In the culture initiation, there are sterilized explants placed on MS medium, which is supplemented with carbohydrates, glucose regulators, and also explants that are adapt to in vitro conditions. Indicators of the success is said to be an healthy shoot emergence with no contamination, a minimal tissue necrosis, which have a controlled temperature, light, and photoperiod. The second thing is shoot multiplication, which is a most critical stage for mass production. In the repeated subculturing technique using cytokine-rich media, this shoot multiplication induces multiple shoots from one explant. This is about to show an exponential increase in plant numbers that produces large quantities in short time, which are economically efficient for commercial use. The third process is root induction, where individual shoots transfer to auxin-rich medium that promotes strong root formation, which are essential for nutrient uptake, plant stability that improve survival after transfer to the soil. The next process is acclimatization, where gradual transfer from the ultra to external condition occur. In initial conditions, we expect to have high humidity and low light so that the plantlets can move to nursery under shade. This shows gradual reduction for humidity and reduces transplant shock that ensures successful field establishment. The final process is revenue potential, where continuous demand for banana plantlets due to year-round of cultivation increases because tissue culture of plantlets sold at higher prices than traditional suckers. High multiplication rate allows mass production and higher revenue. This is because of the reduced disease caused by this process, so that it provides a stable long-term income through repeat demand and partnerships. Perhaps we might have many questions regarding to the process. First thing is why tissue culture ensures disease-free plantlets? Because the shoot apical meristems used are lack developed vascular tissue with rarely invaded by pathogen, such as viruses, bacteria, and fungi. Aseptic lab condition prevents contamination of these meristems and eliminates latent infections found in the suckers. It also helps reduces disease such as Fusarium wilt and also BBTV, which is banana bunchy top virus. The thermotherapy and meristemic excision improves viral removal that produces healthier and more vigorous plants. These are the main reasons why apical meristems are chosen for the process. And the scientific justification for the advantages over conventional propagation is it has rapid multiplication compared to slow sucker growth, produces large number of plantlets year round, it has high genetic and phenotypic uniformity, consistent growth and fruit quality, with earlier flowering and higher yields, lower disease transmission, reduced chemical pesticide use, and more sustainable and environmental friendly product which is higher in market acceptance. Now it's time to discuss about the feasibility. This process is highly recommendable for commercial production because one explant can produce nearly thousands of identical plantlets, where 50,000 to 200,000 plantlets produced in 6 to 12 months, which are scalable to million annually. And this process is supported by optimized media, automation, and also bioreactor enzymes that is cost effective for smallholder farmers and ensures continuous supply of clean planting management. And it is also known for the consistency and uniformity of plantlets, where the explant is derived from a single disease-free plant and provides a uniform culture condition throughout the production, which has high quality targets, which is more or equal to 95% of clonal uniformity, more or equal to 90% of acclimatization survival, and also zero systemic pathogenic impact. This all results in synchronized growth, predictable flowering and harvesting, uniform fruit size and quality that simplifies the management of farm, that helps to improve the yield stability and income, that enhances long-term sustainability. These are the feasibility.
For this section, I will explain the budget and cost analysis for our tissue culture project. The purpose of this budget analysis is to evaluate the financial feasibility of producing disease-free banana plantlets using in vitro tissue culture. It also aims to identify the major cost components involved and potential funding sources while ensuring that the final product remains affordable for smallholder farmers without compromising quality. The estimated total project cost is approximately 55,200 ringgit, which is suitable for small to medium scale production. The largest portion of the budget is allocated to laboratory equipment, which includes a laminar airflow cabinet, autoclave, analytical balance, pH meter, and hot plate. These items account for about 27,700 ringgit and are essential for maintaining aseptic conditions and accurate media preparation. Culture media and chemicals such as MS basil salts, sucrose, agar, plant growth regulators, and sterilants cost approximately 7,000 ringgit and are required for shoot multiplication and root induction. Growth facilities including the growth chamber, culture room setup, lighting and culture vessels require around 12,500 ringgit to ensure control and uniform plant growth. Finally, operational and labor costs including electricity, water and skilled technician support are estimated at 8,000 ringgit to ensure continuous and stable laboratory operation. To reduce overall production costs, several cost-saving measures can be implemented. Bulk purchasing of culture media and chemicals helps lower unit cost, while sourcing materials from local suppliers reduces transportation and import expenses. In addition, culture vessels and glassware can be sterilized and reused multiple times, which minimizes recurring costs. Optimizing shoot multiplication rates also reduces labor time and media usage per plantlet. Share laboratory facilities with universities or research institutions can further reduce initial capital investment. In terms of funding sources, this project may be supported through self-funding, particularly during the pilot production phase. Government, agricultural, and biotechnology grants can provide financial assistance for laboratory equipment and operational costs. Institutional support from universities or research centers may offer shared facilities and technical expertise. Furthermore, partnerships with agricultural cooperatives and local nurseries can provide additional funding while ensuring efficient distribution of disease-free banana plantlets to smallholder farmers.
For my part, I will be discussing the opportunities and business model of this project. The main market opportunity for this project is the increasing demand for disease-free banana plantlets. Many smallholder farmers still rely on traditional sucker propagation, which often spread disease such as fusarium wilt and results in uneven plant growth. Because of this, farmers are looking for healthier, more reliable planting material. Our target customers include smallholder farmers, plant nurseries, agricultural cooperative, and government support farming programs. In terms of commercial value, tissue culture produced banana plantlets offer several advantages. These plantlets are disease-free, uniform, and have higher survival rates once planted in the field. This leads to improved yields, reduced crop losses, and lower spending on chemical disease control. As a result, farmers can achieve more consistent production and better income stability. Next, the business model of this project is simple and practical. Banana plantlets are produced in large quantities using in vitro tissue culture techniques. After acclimatization, the plantlets are distributed through nurseries or directly to the farmers. The pricing strategy focuses on affordability, especially for smallholder farmers, while still ensuring the sustainability of the production system. This project also has strong potential for partnerships. Collaboration with agricultural agencies, nurseries, and research institutions can help with distribution, technical support, and quality control. These partnerships will strengthen both commercial and scientific aspects of the project. In conclusion, this project has good revenue potential in both the short and long term. Through direct plant sales and future scalability, it provides a sustainable business opportunity while supporting disease-free and productive banana farming. That's all.
In conclusion, tissue culture offers a reliable and scalable solution to the limitations of traditional banana propagation. It allows the production of disease-free and uniform platelets, reduce losses due to disease, and support sustainable banana farming, especially for the smallholder farmers.